So today's job, I have a set of trees, each constructed with MaxML, each with exactly the same taxon set, but incorporating different information, different modules of information to add information content. And I want to compare these, see how they differ. There's 6 trees, 6 trees. Some of them will be very similar, some of them will be very different, and I would like to quantify this. A standard measure of this is a Robinson-Foulds index. Now, MaxML will do this with the -f lowercase r switch. It will do calculate Robinson's-Foulds index. But when I do this, I get the MaxML crashes, and the MaxML has given the likely problem, which is this particular function requires unrooted trees, whereas the trees I have are all rooted. So the job today is simply I will unroot these 6 trees and see if then this function will run. I can then calculate RF index. So to unroot these trees, I think I'll just write a bit of Perl code to do this. So it's reading in 6 trees from this file. So let's have a look. And they have been rooted each with this taxon here. And pretty big trees, 1,000 or 2,000 taxon, and you can see that here's the outgroup again here. So this is what we want to unroot. Now to unroot is probably pretty simple. Now it's positioned so that the outgroup is here's the outgroup. So it's the last terminal string at the end of the line. There's a branch length to the outgroup. So rooted is a bifurcation at the root. So we want to turn this to a trifurcation. So probably all we need to do is this here. We need to remove this set of here's the closing bracket, and we need to remove this, and one right at the start of the line, which opens the set. So this will probably turn this into a trifurcation. So I think, and so the outgroup is usually the start or the end of the Newick string, and in this case it seems to be end. So it's probably consistent with the ending position. So we're searching for taxonomic name, comma. Maybe this branch length will need to be removed, and we'll be deleting this to turn it into a unrooted tree. So hopefully that will work. So a bit of Perl code. So I'll start a new text file, and it should be just a few short lines of code, I think. So new Perl script, and we will feed a, maybe do this individually, feed a single Newick into this. So we will run this Perl script on this file name. So reading just the file name, usually better to have some safety commands. For instance, check that the user has given it something that looks like a file name. And let's try opening the file. Okay. So running Perl scripts, we run Perl command and give a path and name of the script, and then any arguments we have for this. We'll just have a single argument here, which will be the file name. So we've got 2 points at which we may terminate the script, here and here. If it's got past this, then it has opened the file. So we can put a message to that effect here. So we've opened the file. Let's read the file. Various ways to do this. This is my preferred way. I have an unconventional way to trim off new lines, and I can't even remember the way why I started doing this, but something to do with different types of new lines from different platforms, and this worked for me at the time. This is how I do it ever since. But it is other. You can use chop or chomp or something like this if you wish. So we're reading all the lines of the file, and we will detect if when we reach a line which looks like a phylogeny, if there's a bracket in that line. So in this conditional here, we have reached a line with the phylogeny. Now I want to unroot this. So let's print maybe just print the line, which will contain the tree. And we want to, as I say, remove, I think this will unroot the tree if we remove this, this branch length here, and it's a bit difficult to find a start. Let's try again. And remove one of these initial brackets. I think that should unroot this. So let's try. Let's make a note of what we're looking at. Yeah. So we'll do a pattern match and then cut out from the pattern what we don't want. So this is a pattern match. The line is the variable containing the line, which if it's within these brackets is a phylogeny, and we're using S. We might use a regular expression to. I'm going to put what we're looking for here and replace it with in a second. For second pair of forward brackets. So we need to develop a regular expression or regex to match this part of the Newick string here. So first, we're looking for close bracket. Then we've got a colon. We've got a branch length. Then we've got a comma. Then we've got our outgroup. So we could actually give the outgroup name, so we can. Might be a good idea. We'll just give the outgroup name as a switch. Then we've got another colon and another branch length. Then a closed bracket, semicolon, which always terminates a Newick string. So this should match this part of the string. Now, well, remember, we've got to give we'll give the outgroup name as a second argument. Okay, so this should match this part. We'll check that it does in a second. We'll just need to, so we'll be deleting this and perhaps the branch link, and we will be retaining the comma, the outgroup name, colon, branch length, and everything else. So we capture this part of the match, and so we can retain that $1, which will contain everything within our set of brackets. So that will capture this and we'll keep that, and just this part will be deleted here. Perhaps we need to also confirm this has matched. Okay, let's try this. Okay, good. Looks like there's been a match, and we've retained this part, so this one would have been deleted. Okay, secondly, we've deleted the second in the set of the parentheses. We just now just need to delete the first. We can just delete the first character. We just delete the first character. So start of line is the upward pointing arrow, and then open bracket. So we'll match the first open bracket of the line and replace it with nothing. So that's a deletion. Okay, so both of these have been done. So this, I think, should unroot the tree, but I'm not certain. I haven't done this before. Don't remember doing this before. So we'll now print this to an output file, and then try it. Maybe, but also need to count. In case we run this on multiple trees. We need to print the modified Newick string to the output file, to an output file. So the file handle we can call out. Then we need to give a new file name and call it unrooted. So we need to open the file handle, close the file handle, and write to the file handle, which we'll do after we've modified the Newick string. Okay, Control S, save, run, and we have a new file. have a look. Okay, so this is the original string. Modified, we have indeed looks like we have cut out this. Okay, so we have now let's run this on each of the all of the 6 trees file containing the 6 trees here. Okay, now made 6 matches on each of the 6 trees. This gives us hopefully an unrooted set of trees. So we'll try again to run RaxML. So we're doing the -fr, which is the Robinson-Foulds index. As I say, I ran this on a set of rooted trees, and the error message suggests it needs unrooted trees, which we've now unrooted. And we've got outgroup and usual set of switches for XML. So we'll insert a new file name with the unrooted trees, and let's try again. No error message. This seems to be the output file. Yep, and this looks like an index. So our input file had six trees. And this refers to pairwise comparisons. So index 0 to 1, there's the Robinson-Foulds index. Presumably is in this column here. So these 2 trees are identical, I guess. So varying distances between these 6 trees. Okay, I think that's our job done. Maybe one more quick look at our solution was to match to unroot a tree by removing a pair of parentheses, changing it from a root bifurcation to root trifurcation. Now, one thing we might do is, I think sometimes the outgroup is not the last, not the final, not necessarily the final thing in the Newick string. Sometimes it can be the first. So I'll do if we develop the script further, perhaps one thing would be to check if this has not been matched, and then we'll try and reverse this and match just the start of the Newick string instead, looking for the outgroup at the start of the string. So perhaps we would have a warning message here to alert the user if there's no match made, and this might be required. So otherwise, this is working for our current purpose. Okay, so that's all for today.